Assalamu alaikum everyone. I am Sumaya Afrin from 19B and my bearing ID is 181291232. I am presenting our presentation about pharmacokinetic model. So let's see. Pharmacokinetic model, what is it? It provides the mathematical expression for the time course of drugs throughout the body and compute the meaningful pharmacokinetics parameters. The types are three. These are the compartment models, physiological models, and distributed parameters of models. Here, the compartment model has two types, which model is mammalian model and catenary model. There are two types of compartment model division, and compartment model is a traditional way to represent of a drug, and it interpolate the experimental data and estimate the drug's concentration with the time. Now we will see the mammillary model. Mammillary model is joined parallel to the central compartment to the peripheral, and the central compartment comprises the plasma and highly perfused tissues such as liver, kidney, etc. The parallel diagram of mammalian model will be like that. Here it is. Q1. As it parallel and reversible, that's why the diagram will be like that. Now the catenary model. The catenary model joined the one another in a series like compartments of a train. So the diagram will be like this. The arrow will be the same way. And they are mainly anatomically and physiologically various organs are directly linked to the blood compartment. Now the physiological models. It presents a more realistic picture of drug deposition in various organs and tissues. Here is a diagram I have shown here. It's a my self-analyzed diagram for physiological models. In our physiological means this is related to the anatomical way in our human body, because when we intake a drug, the absorption will be gone through about the diagram. Now the distribution model. In distribution model, there are variations. There is variations in blood flow to an organ and variation in drug diffusion in an organ. These are the main cause of distribution model, but it is really cost effective and time effective. So this is a model which is poorly used in pharmacokinetic models. Now one compartment model is denoted by dx by dt equals to dx by dt minus. In one compartment open model, dx by dt by this diagram we will decide the drug dose system. When a drug is administered by our extravascular route, absorption is prerequisite for its therapeutic activity. One compartment model is related to extravascular administration. It is also related to the zero order rule and first order rule, but I have gone not describing here it now, because I have described it in my assignment. For our time shortness, I am converting in my next slide. The two compartment open model. Two compartment open model is two types. It's elimination and distribution. It's intravenous bolus administration. It is called intravenous bolus administration. because after the intravenous bolus of a drug that follows two compartment kinetics, decline in plasma concentration is indicate the presence of two deposition process. That's why they are called distribution and elimination. Initially, the concentration of a drug in the central compartment declines rapidly. This is due to distribution of a drug from the central compartment to the peripheral compartment that is hold to the body. The last of all, the non-compartmental analysis, which is denoted by MRT and AUMC by AUC. After integration of AUMC and this, we will get AUC is equals to here MRT is the experimental data following of a single dose of a drug. And now the Michaelis-Menten equation, which is most widely used compartment model of pharmacokinetics model, which is denoted by dC by dt equals to Vmax C Kmax plus C. Here Km is the Michaelis constant and C is variable, and Vmax is theoretically rate of the process, and dC by dt indicates the rate of decline of drug concentration with time. And the last of all, I would like to add some application of pharmacokinetic models, which is mainly used for characterization of a drug and evaluating the bioequivalence of plasma drug concentration, etc. That's all about my presentation topic, and this is all about by pharmacokinetics compartment model. Thank you.